Okay, for the HydroBot3000 circuit board, this is my setup. This robot is meant to independently move with 4 independently run DC motors attached to the wheels and axles of the robot so that it can turn and operate as basically a Roomba would. This robot is powered from a 9-volt battery as well as the 5-volt hookup from my Arduino to the breadboard. For my setup, I have each of the DC motors hooked up to each of the output values on the breadboard. For my Arduino pins, I have 3, 5, 6, and 9 live and attached to the input values on the L293D. Pins 10 and 11 on the Arduino are linked to enable 1 and 2 and enable 3 and 4 on the L293D. This will help ensure that we can control the motor speed for each DC motor. In my code, I've initialized all of the motor pin variables between motor pin 1, 2, 3, and 4 and assigned them accordingly, as well as the motor speed 1 and motor speed 2 pins on 10 and 11. I've also initialized an action driver for 1 to help run my while loop. In the setup, I've initialized with serial begin and set up all of my pin modes for all of my motor pins and motor speed pins to an output value. My while loop has an extensive build out because each function does not loop exactly the same. I've broken my while loop sections up accordingly based on the actions that they're completing. So for the first action, I have my digital write on all of my motor pins to run high with the motor speed 1 and 2 for all 4 DC motors to run at a speed of 10. They will move forward for 5 seconds and then stop. After stopping, they'll wait 2 seconds before turning on motor pin 1 and motor pin 2 to make a right turn for 1 second. After turning right for 1 second, all motor pins will stop and delay for 2 full seconds. After the delay, it'll move forward again for another 5 seconds to travel to the right corner of the setup. Once it's been 5 seconds, it should be in the right corner of our robot setup, and it will stop. After stopping and waiting for 2 full seconds, it will turn 180 degrees for 2 seconds until it stops once more. Once the robot is stopped in the backwards position, it will travel 10 seconds forward to travel to the left corner and stop. After 2 seconds of stoppage, it'll perform another 180-degree turn for 2 seconds, stop, and then move forward 5 seconds to return to the center and stop. The robot will then make another 90-degree turn to the right, stop turning, and then move forward to home for 5 seconds and stop. The robot will perform another 180-degree turn and stop turning to return it to its home location. Outside of the while loop, I have it set to delay for 1 full hour so that this loop runs every hour. When I simulate the code, you'll see that all 4 DC motors will power forward for 5 seconds, stop for 2, and then turn. Power forward for another 5 seconds, stop, turn, and go forward again. This operation will run until it's performed all actions and back in its host location.